Good day everyone. In this lesson, we're gonna talk about regression. Its meaning, importance, where and when the regression is being used, as well as the formula for finding the regression line.
So what's the importance of regression analysis? Why should I use it? Regression analysis is a powerful statistical method that allows us to examine the relationship between two or more variables. It also refers to a method of mathematically sorting out which variables may have an impact. And the importance of the regression is that it helps determine which factors matter most and how those factors interact with each other. Regression is a statistical method used in finance, investment, and other disciplines that attempts to determine the strength and character of the relationship between one dependent variable, usually denoted by y, and a series of other variables known as independent variables. For example, you want to see which type of fertilizer helps plants grow fastest, so you add a different brand of fertilizer to each plant and see how tall they grow. Type of fertilizer given to the plant is our independent variable. Independent variables are variables that are manipulated or are changed by the researchers, and whose effects are measured and compared. The other name for independent variables is predictors. The independent variables are called as such because independent variables predict the values of the dependent variable. Next, we have the plant height. Plant height is our dependent variable. Dependent variable, on the other hand, are also considered the dependent variables. We can say that the dependent variables are the type of variables that are completely dependent on the independent variable. The other name for the dependent variable is the predicted variable. The dependent variables are named as such because they are the values that are predicted or assumed by the predictor or independent variables. Regression. A statistical measurement used in attempt to determine the strength of the relationship between one dependent and series of other changing variables. Next, we have regression line. It enables the researcher to see the trend and make predictions based on the data. It is the data's line of best fit. And the purpose of running the regression is to find a formula that fits the relationship between the two variables. Note that determining the regression line when r is not significant and then making predictions using the regression line are meaningless. Best fit means that the sum of the squares of the vertical distances from each point to the line is at a minimum. Tips for drawing a line of the best fit. First, we must determine the direction of the slope. Next, draw the line in the middle of the data as best as you can. You can try to have an equal number of points on both sides of the line of the best fit. And finally, the dot should be an equal distance from the line of best fit. If the scatter plot has a strong correlation, the line of the best fit is easy to draw in. And if the scatter plot has a weak correlation, like this example, the line of the best fit can be a little more challenging. Remember, you want to try to have a line of best fit in the middle of the dots and an equal number of dots on both sides. Then, if you have a scatter plot that looks like just a bunch of dots, then you have no correlation. Let's proceed to the determination of the regression line equation. In algebra, the equation of a line is usually given as y is equal to mx plus b, where m is the slope of the line and b is the y-intercept. In statistics, the equation of the regression line is written as y prime is equal to a plus bx, where a is the y prime intercept and b is the slope of the line. Next, is the rounding rule for the intercept and slope. Just simply round the values of a and b to 3 decimal places. So now let's proceed to the formulas for the regression line y prime is equal to a plus bx. A is equal to the summation of y multiplied to the summation of x squared minus the summation of x multiplied to the summation of xy all over n multiplied to the summation of x squared minus the summation of x quantity squared. B is equal to n multiplied to the summation of xy minus the summation of x multiplied to the summation of y all over n multiplied to the summation of x squared minus the summation of x quantity squared. Where a is the y prime intercept and b is the slope of the line. So let's proceed to the example, which is the car rental companies in the United States for a recent year. Given the set of data, companies A, B, C, D, E, and F, the cars in 10,000s, 63.0, 29.0, 20.8, 19.1, 13.4, and 18.5, as well as the income in billions. Since this is from the United States, the currency we will use is a dollar sign. So we have here 7.0, 3.9, 2.1, 2.8, 1.4, and 1.5. Step 1. Make a table. First, we have the companies A, B, C, D, E, and F. Next, we have the column for the cars in 10,000 denoted as X. Then we have the income denoted as Y. Step 2. Find the values of xy, x squared, and y squared, and place these values in the corresponding columns of the table. Since we already have the data for the column of company, cars, and income, now we will solve for the data or the value in the column of xy, x squared, and y squared. Let's proceed to the column of xy. Just simply multiply x to y. Next is in the column of x squared. By squaring the given value in the x column or by multiplying the number to itself. And lastly, the y squared column, where you will square the given value in the column of y. Now that we have completed the data in the table, at this point, we have to compute for the summation of each column. First, we have to compute for the summation of x. Summation of x is equal to 63.0 plus 29.0 plus 20.8 plus 19.1 plus 13.4 plus 8.5. Summation of x is equal to 153.8. Then the summation of y, 7.0 plus 3.9 plus 2.1 plus 2.8 plus 1.4 plus 1.5. Summation of y is equal to 18.7. Next we have the summation of xy. 441.00 plus 113.10 plus 43.68 plus 53.48 plus 18.76 plus 2.75. The summation of xy is equal to 682.77. Next is the summation of x squared. The summation of x squared is equal to 3,969.00 plus 841.00 plus 432.64 plus 364.81 plus 179.56 plus 72.25. The summation of x squared is equal to 5,859.26. And lastly, we have the summation of y squared. 49.00 plus 15.21 plus 4.41 plus 7.84 plus 1.96 plus 2.25. The summation of y squared is equal to 80.67. Step 3. Substitute in the formula to find the value of r. Given the formula, r is equal to n multiplied to the summation of xy minus the summation of x multiplied to the summation of y all over the square root of n multiplied to the summation of x squared minus the summation of x quantity squared times n multiplied to the summation of y squared minus the summation of y quantity squared. We have to substitute this given data in the formula to compute the value of r. So r is equal to 6 multiplied to 682.77 minus 153.8 multiplied to 18.7 all over the square root of 6 multiplied to 5,859.26 minus 153.8 squared times 6 multiplied to 18.7 minus 18.7 squared. So r is equal to 0.982. Since the value of r is computed from the data obtained from samples, we can say that r is significant because r is near at positive 1 and negative 1. Step 4. Find the equation of the regression line and graph the line on the scatter plot of the data. To substitute this given data in the formula to find the equation of the regression line, where a is equal to summation of y multiplied to the summation of x squared minus the summation of x multiplied to the summation of xy all over n multiplied to the summation of x squared minus the summation of x quantity squared. And b is equal to n multiplied to the summation of xy minus the summation of x multiplied to the summation of y all over n multiplied to the summation of x squared minus the summation of x quantity squared. First, we have to compute for the value of a. A is equal to 18.7 multiplied to 5,859.26 minus 153.8 multiplied to 18.7 all over 6 multiplied to 5,859.26 minus 153.8 squared. A is equal to 0.396. Next is to compute for the value of b. B is equal to 6 multiplied to 682.77 minus 153.8 multiplied to 18.7 all over 6 multiplied to 5,859.26 minus 153.8 squared. B is equal to 0.106. Use any x values between 10 and 60.
For example, let x is equal to 15. We need the value of a and b to find the corresponding y prime value. Next is substituting a and b values in the equation y prime is equal to a plus bx. Y prime is equal to 0.396, which is the given value of a, plus 0.106 multiplied to 15. Y prime is equal to 0.396 plus 1.59. Y prime is equal to 1.986. Next, let x be equal to 40. Y prime is equal to a plus bx. Y prime is equal to 0.396 plus 0.106 multiplied to 40. Y prime is equal to 0.396 plus 4.24. Y prime is equal to 4.636. Then plot the 2 points 15 and 1.986 and 40 and 0.106 and draw a line connecting the 2 points. We will now plot the points that we have computed and make a scatter plot to find the equation of the regression line. The equation for the regression line is y prime is equal to 0.3963 plus 0.1061x. Therefore, we can conclude that there is a strong relationship between independent and dependent variables, and that our scatter plot has a strong correlation because the line of the best fit is easily drawn. We have equal number of points on both sides of the line of the best fit, as well as the dots having an equal distance from line of best fit.